I'm Steve Robertson. I'm a professor in the Department of Human Development here. And this is my introductory slide because I guess my daughter drew it when she was about 6 at the time when we moved here to Ithaca in 1988. So you can figure out how old she is now. It's important because even at 6, she had a pretty good idea of what I did for a living. And I want to point a couple things out to you. First of all, actually, most important, notice that the way she wrote my name, Steve Robertson, notice the ERT is big. Turns out, you think a name like Robertson everybody would get? Not so. At least, well, roughly 50% of the time, I'm called Robinson instead of Robertson. And so that was such an irritation to me and somewhat to my family that when we came here, I had T-shirts made. It had Robinson on the front with the international no symbol, and Robertson with big ERT on the back. And apparently that made a big impression because when she was 6, she did this big ERT there. Anyway, on the left here, this is a baby, okay, holding a bottle and a doll. Those are not voodoo pins. Those are those are balloons. And the baby's screaming, right? Screaming bloody murder. And then over on the right here is Dad. That's me, with a baby with a very small head throwing up on me. So like I said, and then down at the bottom here is Data. That was her idea of my data. Actually, not bad, as you'll see. But so this is me, and what I was doing then, studying babies. I had been for a while before I came to Cornell, and I still am. But what about this? Have you seen this? Okay. Study reveals babies are stupid. Los Angeles, I'm going to read this to you, okay? Los Angeles, a surprising new study released Monday by UCLA's Institute for Child Development revealed that human babies, long thought by psychologists to be highly inquisitive and adaptable, are actually extraordinarily stupid. The study, an 18-month battery of intelligence tests administered to over 3,500 babies, concluded categorically that babies are so stupid, it's not even funny. And then this is a quote from later in the article. As a mother of 4, I find these results very disheartening, Bentley told reporters. I can honestly say that the effort I have expended trying to raise my children into intelligent beings may have been entirely wasted. A fool's dream, if you will. So, why study infants? By the way, I have to tell you, that previous article was a joke, okay? In case it wasn't clear. It's a piece from the magazine, well, it's now totally online, used to be both. The magazine called The Onion, and does news, satire, and other kinds of satirical stuff. But the question is, really, why do I and other people, I'm a reasonably smart guy, why do we study infants? Well, there's a whole bunch of reasons. I'm going to describe 2 sets of reasons to you quickly. The first are reasons having to do with science and philosophy. For example, deep questions. It turns out that some of the questions that human beings have been struggling with for millennia, such as the role of nature and nurture in how we turn out in our lives, the relationship between mind and body, the non-material, according to Descartes, and material aspects of ourselves. Those questions have been extraordinarily difficult to answer. And interestingly, infancy, especially early infancy, turns out to be a time in life when you can get some leverage on those questions and get some clues as to possible answers. And the reason is that it's a time in life when experience in the world has been minimal. That allows you to make some stronger inferences about what those initial conditions are, how we start out in life, and then how other aspects of ourselves emerge over time because of the interaction of those initial things that we have and the conditions that we find ourselves in. Well, there's also, I have to confess, one of the things that motivates me the most is the challenge. All science is a challenge, and that's, in a sense, what makes it fun for us to do on a day-to-day basis. But I have to point out, this girl is a couple of minutes old, still connected to mom, right? She's already got an attitude. You see that? Isn't that amazing? This attitude turns out to be the challenge in studying infants. Infants are not cooperative beings. They don't follow instructions. They don't even understand instructions. So it becomes a great challenge to try and figure out what's going on inside her head. How can we do that? Okay? And the sort of the methodological challenge, the technical challenge of doing that is something that motivates a lot of us that study infants. It also motivates people who study non-human animals too, but that's the way it goes. Okay, there are other reasons besides science and philosophy for studying infants, human beings early in their life, and that has to do with what I'm just calling broadly clinical application. That is, trying to figure out what we can do to make lives better, what we can do early to make lives later on better. And I've picked here one example, which is being born too soon. Preterm infants, especially those right at the limits of viability, around 23 weeks or 24 weeks of gestation into pregnancy, 40 weeks is full term, face enormous challenges in their lives. This is a picture from the rooftop, the helicopter pad at CHOP, Children's Hospital of Philadelphia. And this is another picture from inside in the ICU, NICU. And this is, if you've ever listened to Radiolab, this is actually, if you're interested in this at all, this is actually worth going to and checking out. The name of the show, the program for that day, was 23 weeks, 6 days. And it's an interview with a couple who had their first child, was born at 23 weeks and 6 days. And it's an interview and a short video about how that was for them. But this is a good example of how some major convergences of basic and applied science take place. The basic understanding of how lungs work this early in development, how the brain works this early in development, and what challenges are faced by the organism that's all of a sudden outside of the womb instead of inside of the womb. And how can we engineer, how can we alter the ecology of this environment, for example, in the intensive care unit, in order to facilitate optimal development. So these are, by the way, I should say that these issues, especially early in life like this, also raise a lot of very serious ethical issues, having to do, for example, about the quality of life that's saved. So it's an important area, and it represents one of the main reasons that a lot of us study early development. This is a kind of setting that I worked in before I came to Cornell. All right. So as I hinted, we do both kinds of work in my lab, both basic science and clinical application, or clinical research that might have an application. Interestingly, I'm going to show you a quick video. It's 2 minutes and 36 seconds. That was not made by me. It was made by a guy who brought his baby into the lab. A couple of years ago, this father and mother brought their 3-month-old into the lab, and to participate in an experiment that we were doing. And, you know, I think you could probably imagine it's not uncommon for parents to ask a lot of questions and take a lot of pictures and so forth when they come into the lab. You know, we had to put this thing on the baby's head, record brain activity. They sit in a special seat. It's, you know, it's a funny sort of arrangement, not one that they see every day. And they're interested in taking pictures of it and so forth. So we didn't think twice when this guy was taking a lot of pictures and asking a lot of questions. Little did we know, but turns out he was the assistant director for social media in the Cornell's Office for Alumni Affairs. And, and he ended up, kind of sketchy on my view, he ended up putting together this video without telling us about it. And then, at the last minute, before he posted it on YouTube, he had a question. That's how I found out about it. Turned out okay, everything turned out okay. But I'm going to show it to you because, well, it gives you a sense of what we do, but from an outsider's view, you don't have to hear me say it. You can hear him say it, and he's also a parent, and his 3-month-old son is in the chair, so to speak.
Babies. They're adorable, but what are they hiding? What secrets are they not revealing in their first few months? My curiosity led me to Cornell's Human Ecology Department, where, thankfully, they're attempting to answer exactly that. Professor Stephen Robertson, with help from his brilliant assistant Katie Jean, is researching how babies seek out and construct information from the world around them.
So we've progressed, and now what we're looking at is how the attention changes before the baby looks away, because it's often the attention will drop before a look away, you know what I mean, even though their gaze changes differently than their attention. Okay. Usually they're correlated, but right before a look away or right after you look onto a new stimulus, their attention might not correlate directly to their gaze.
Considering the importance of the research, I decided it was only right to donate my baby's brain to science. Someday, I hope he'll return the favor. By measuring a baby's gaze and the brain's reaction to sight and sound, the team hopes to learn more about how babies interpret the environment around them.
We measure the attention with the cap that we have in his head, the EEG cap, and then we measure his gaze, and what we're really looking at then is how sound affected that. Did sound make him look at the center duct longer because that's where the sound was coming from, or did sound, if he were in nature, would sound mean danger, and would that broaden his scope, and so he'd be paying attention and looking at different ducks, so.
You're so adorable!
If all goes to plan, this research will help unlock the secrets to understanding how a child develops disabling conditions such as attention deficit disorder and hyperactivity, diseases that affect 2 million children in the USA alone. As a parent, it's reassuring to know that Cornell is playing a pivotal role in combating illnesses that affect so many children. This is invaluable research that has the potential to have a huge impact on the world around us. Hopefully, my son's brain will help Professor Robertson make groundbreaking discoveries in human development. In the end, I may not have learned everything he's thinking, but now I know a great exercise for putting a 3-month-old sound to sleep.
Okay. Full disclosure, most of our experiments don't end with a sleeping baby. They end with a crying baby. Okay, that's it. If you have questions about why on earth do I study these things and or anything about ADHD or preemies or anything like that, I'll be happy to take them.